Hello guys, and welcome to my YouTube channel. In this video we are going to be talking about the power IC of a mobile phone. The power IC. So in this phone, this is the power IC of this mobile phone. So from the word power, you know that it deals with voltages, or is responsible for distributing the voltage that is required to power up the other sections in the mobile phone. So when you can easily identify the power section by the inductors that you see around and the capacitors. You always see them many around the power IC. So it helps the power IC to take the voltages and distribute to other components in the mobile phone. If I show you this other motherboard, you can see the power IC is there. You can also see those capacitors and the inductors. And this one is the same. You still see the capacitors and the inductors. So the power IC, as we said, helps to distribute the voltage to other components in the motherboard. Now, if you check carefully, you are going to see that there are certain capacitors, these ones. These capacitors are in parallel. Or you see them like this. They are in parallel. So the voltage that is coming to these capacitors will be distributed to all these capacitors here. If the voltage that is coming here is 3.7 volt, so each of these capacitor is going to have 3.7 volt, and then they are going to pass it into the power IC for it to produce the responsible voltages that is required so as to be distributed to the capacitors and inductors, and they will take it to the various areas or the various sections in the mother phone. Now, these capacitors here get the input voltage that is required to power the power IC from the charging IC. This is the charging IC. Now, how can we know that the component here that is connected, or that is bringing the voltage to these capacitors in order to supply the power IC? So in most cases, you always see these capacitors. They are always close to these coils. You always see them. They are always in the side of this coil. If I take another motherboard, you also see the same thing. This is another motherboard. You can identify the capacitors, right? You always see them. They are always at the corner of the coil. You see them. These are the coils, and then these are the capacitors. You always see them at the corner of those coils. At the corner, you see this is another motherboard. You see the capacitors are here, and then these are the coils. Now, how can you know the voltage, the component that is bringing the voltage, if you don't have a schematic diagram, especially for those of us who do not have a schematic diagram? How can you know the component that brings the voltage to the power IC? So what you can do is, you have to come to the charging IC. This coil is responsible for bringing that voltage, that 3.7 volt or 4 volt, to the power IC. Now, in order to measure it, to know, what you have to do is, you are going to put your multimeter. You are going to put your multimeter on buzzer mode. Then you are going to measure the reading, the diode reading of that inductor. Let's measure it and see. You see is giving us 2 or 3. It's giving us 300. Both sides will be 300. Okay, let's check those capacitors. You also see it gives the same reading. Okay. Can you see that? It's giving us 300. So if I test all these capacitors, they are going to give the same reading. 300. 300. 300. area 100. So you see that all the values are the same, meaning that these capacitors here are connected in parallel, but with this inductor, they are connected in series. With this inductor, they are connected in series. You see that they have the same value. So if one of them gets short, like this inductor, if the inductor gets short, it is going to short all those components that are connected to it, like the capacitors. See there, it's going to short all these capacitors. If I take another motherboard, you also see the same thing. You see those capacitors, and then this capacitor also gets. Let me take this one. That is simple. Okay, see, this is the charging. This is the charging section of this mother phone, and now this is the power section. So you also see that this charging section is bringing the voltage into the power section through this resistor, but is the output. Is the output. The input is here. These are the output. Now, if I measure the reading, you also see the same thing. Let's measure the reading. You also see that is the same. That is 350. 350. Let's measure those capacitors and see. You can see 350. 350. You see that the value is the same, meaning that this resistor is bringing the voltage into those capacitors to supply the power IC. Then if you want to also test it again, you can still test it with continuity mode. Put it here, and then you can see that it has a, when it's beeping, means that there's a continuity mode from there to the power IC. So in order to know if the voltage is coming into the power IC to supply this power IC, what you can also do is you can connect the battery into the phone, and then even without powering on the phone, the voltage is going to pass through the power charging IC and come to this resistor in order to supply this power IC. So you can also check the voltage by connecting the battery, and then you check it here. You also come and check it here. If you don't see it here, then this man is having a problem. The same thing also goes with this one. So you have to also do the same thing. Here you have to also you can connect the battery, and then you check. You connect the battery here. Then you check the voltage from here. You check the voltage. If you see the voltage here, that means that the voltage has to come and supply the power IC through these capacitors. You also see the same voltage here that is going to enter the power IC, and the power IC is going to boost that voltage into different voltages and then distribute it to all these components that you see here that are going to take the voltage to the other component or the other sections. In some cases, if you don't see the voltage, the phone is dead, sometimes it can still be the power IC. So what you can do is, for example, in this motherboard, this is the power section. This is the power button. This is the power button here, the jumper point. But the power buttons are here. The power section, the button here is here, the power button. Now what you can do is, if the phone is not switching on, sometimes it can still be the power IC that is not sending the voltage that is required for the phone to switch on. So what you can do is, you can just take your multimeter and then connect the battery, and then put the multimeter to the voltage. Put it to the voltage mode, and then you just come and test this power button to see if there's a voltage on the power button. If there's no voltage, then you have to hit up the power IC, or sometimes you may have to change the power IC. So I hope everything I said is understood. So like I said, these capacitors here are in parallel. That's why you see them are having the same resistance diode mode or resistance mode. They also have the same voltage that is going to be required to send it into the power IC in order to boost the voltage. And then they are connected with this coil in series. That's why the coil is here. So I hope everything I said is understood. And then if there's something you don't understand, you can send me a message in the comment section. Please subscribe to my channel and hit the like button so that each time I upload a video, you'll be able to see it. Thanks for your understanding and for your cooperation, and see you in the next video.